This video is a primer to tell us how to do all conversion problems. And most of what you do in chemistry is going to be a conversion problem of one kind or another. So in this one, we're going to first of all start out with looking at the thing that has the number with it, and that's milligrams. So I'm going to take the number and the unit of measure, and I'm going to put that down as one of my givens, one or more of my givens. 526 milligrams. So I take my 526 as the given, and it says here that I'm supposed to convert it first of all into grams, and then I'm going to take it to kilograms. And I can do this all in one step, which is really nice. So in my find, I've got to put that down. First of all, how many grams does that represent? And secondly, how many kilograms does that represent? And so we have to do this as a two-step problem. Normally I would do it all in one string of fractions, but this one requires it to be a little bit differently. So my first part of the problem is to figure out which one of the qualities over here is going to help me get to where I want to go. So I'm starting in milligrams. Okay, that was the given. Right there. So next I have to figure out, do I have equalities that I can use that will get me from milligrams into grams? So I look for something that has milligrams on one side and grams on the other. And the bottom one is it. It's got it. Now this one isn't going to help me because that's liters. And this one won't help me, at least in the first part of my problem, because this is grams to kilograms. And right now, I'm going milligrams to grams. So I just happen to have an equality here that will work for that. So the next thing I want to do is realize that I'm going to have a second fraction. I'm going to have milligrams on the bottom of that second fraction. And the reason for that is that I will be able to cancel milligrams and hopefully have the unit that I'm looking for, which in this case is grams, as the other number. So I look over here, there's my milligrams, and the number next to it is 1,000. So what I'm going to do is take my 1,000 and put that next to milligrams, because the numbers always go with the unit of measure that they are written next to. So you might want to think for just a moment, turn off the recording, and figure out what is going to be on the top and why. Okay, turned off, think. Now I hope you did that. I hope you did some thinking, and you can see here that milligrams is equal to 1 gram. The 1,000 milligrams is equal to 1 gram. And so I'm going to put the 1 gram on the top. And now you say, hey, wait a minute, Mr. Weir. What are you doing? That doesn't make any sense to me. Well, here's what you have to understand as background. A equals B. What does that mean? That means that if A is equal to B, that when I divide A by B, that's going to be equal to 1. That's very, very good information. And why is that? Because anything that equals something else when you divide the two, since they're both the same, like 1 divided by 1 is 2. It's 1. Whoops. And 5 divided by 5 is 1. And 1 million divided by 1 million is 1. Anything divided by itself is 1. So the other neat thing that I can do is I can put my fraction upside down, which is handy depending on which way you're trying to go with your conversion. And so that's equal to 1. Pretty cool stuff. That's why I can get away with this. And it works. So now that you understand these two facts, it makes it easy to see why you can use this both ways. You see, you can have grams on top. If I was going from grams to milligrams, then I'd have grams up here, and this would be down at the bottom, and this would be up at the top. But just remember, whatever is next to the unit of measure has to stay with that unit of measure. So when you turn these dudes upside down, you got to take the unit of measure along with them. You can't just take the numbers. Okay, so at this point in time, we are essentially done with this problem. Now all we have to do is pull out our calculator and get the number. So after running my calculator, this is the number I come up with, and I get that by punching in the 526, the number that's on the top, and then divide it by the number that's on the bottom. Notice this number is in the second fraction, but it still divides into this number. And that's why this becomes our answer. Okay? Let's go on to the next one. We can do that a little bit faster. Okay, on this problem, we look at this and we see that this number is next to milliliters. And that's a dead giveaway that this guy has to be our given. So, for the given, we're going to write 4,320 and the unit of measure next to it, milliliters. Over on the find, we've got liters. And I just realized we've got to sandwich in the end of the last problem. So let's go do that. I apologize for that. In this problem, the second part, or the second answer, is going to be taking, let's get this guy up here, is going to be taking this dude and making it the new given. So this will be over 1 now. And so we can take 0.526 grams over 1 times, this time we're looking for something that takes grams to kilograms. See, here's our kilogram one, and the kilogram dude is right there, and the given one was right here, which was grams. So, do I have an equality up here that takes me from grams to kilograms? There it is. Wow. Okay. Grams on one side, kilos on the other. So, like I did before, I have to take this guy and put it on the bottom of the second fraction. So I take grams down here, grams up here, and I cancel. Now I have to look up at the equality that I'm using and see what the number is that's next to grams. That's 1,000. So we're going to put our 1,000 down here. And on the top, we will have 1 kilogram. So, once I've done that, you'll notice that the number next to kilograms in the top right corner is 1, and the number next to grams in the top right corner is 1,000. And now I'm ready. All I have to do is divide by 1,000 again, and this time the decimal will move over 3 more to the right, or to the left. And that makes 0.000526, and this time we are in kilograms. And that was the second part of that last problem. So we had 2 answers for that. Now let's go down here and deal with this guy. Do we have something that takes us directly from the unit of measure that's in the given to the unit of measure that's in the find? And we look up here and we see that we got mils here. That's the only place we have mils. And we got liters. Bingo. That's our dude. Okay, now just like before, we're going to take our given here and that'll be our start. So report 4,320 milliliters over 1. And now we look up here to see if we've got anything that'll take milliliters to liters, and there's our dude. Okay, mils to liters, 1 conversion, no problem. So, what we do, just like before, we circle this, make our next fraction, and the mils goes on the bottom. So the number next to mils is 1,000, and so that's going to go on the bottom because that's the number next to mil in the equality, and then the other side of the equality goes on top. And that gives us the only thing left as liters, and then all we have to do is pop our calculator, or you should know that this is going to be 4.320, and that's not mils, whoops, that's going to be liters. Okay, and that's our answer to that guy. All right, let's move on. Okay, in our last problem, we have 2.5 grams per liter is going to be put into kilograms per liter. So basically all we have to worry about, and let's go ahead and get up the given and find, it's 2.5 grams, and instead of writing it the way you see it up here, get rid of this slash and make sure you know what that really means. And that is that the 2.5 grams is on top of a fraction, and and let's rewrite it to make it part of starting the problem. 2.5 grams over 1 times, and we got to have grams here, so grams is down here. And now we look up there and see this 2.5 grams over liters. Sorry, almost forgot that. And so this is 1 liter here. All right, and the find is kilograms per liter. Now this is confusing to a lot of students, but understand the guy on the bottom is the same, so you don't even need to worry about him. Just know that he's going to have a 1 next to him. Okay, so the number to get grams into kilograms. Aha, there we go. It's a one-stepper again. So the number next to grams is 1,000. And the number on top will be 1 kilogram. And now you can see the grams are out of here, the liters are not, and the kilograms are not. So our unit of measure at the end is kilograms, or kilograms. That's right, left it off there. So we got kilograms, and on the bottom of the fraction, just like we were originally, we have liters. And now we can simply divide 2.5 by 1,000, and that moves the decimal 3 to the left. So that's 0.0025. And that's the answer for this guy. We could go a little faster this time because you kind of have the basics now. Remember that the decimal starts here and moves 3 to the left because there's 3 zeros in 1,000. And that tells you when the thousand's on the bottom that the decimal is moving to the left. If the 1,000 were on the top, then we would move the decimal to the right. And that's it. I hope you find this helpful.